So yes, you did get an introduction to evaluating logs last year. This whole concept right here, being able to flow back and forth between the logarithmic format and the exponential format of your expression is going to be very big. It will be necessary as we go on in this chapter, as we will use it more and more as we solve exponential and logarithmic equations. We'll use it a little bit today, but mostly just practicing moving back and forth, not necessarily to solve our equations, a little bit. But the underlying thing that you need to get from this is that the base of the logarithm will always be the same as the base of the exponent. So the base will never change. Base of the logarithm is the same as the base of the exponent. It's remembering this order right here. Where does each of these numbers go? This will never stay the same here. Okay, so it's not like that's the base to the exponent. Okay, it's actually this raised to that number gives me this answer. B raised to the y will give you whatever is inside of the logarithm. Yes, absolutely. This should look very familiar. A lot of logarithmic stuff that we're talking about today. We might add a little extra wrinkle to it. But the things that you do need to know about your logarithm is this. This number down here, b, can never be a negative. It also can't be 1. X can never be a negative number. Now they are going to eventually try to trick you and throw one of those out at you and say, what is log base 2 of negative 8? No solution, right? If you have a negative show up here, if you have a negative show up here, there is no work to be done. You stop and say no solution. We can't do a logarithm problem where there's a negative in either of those spots, okay? And the problem is we get going so much into this that we forget that. We'll remind ourselves, but it doesn't show up very often. One of the things we need to practice is I want you to look at that like formatting that I just showed you on that first slide, and I want you to fill out this chart. You can see all 6 of them on your note sheet. Go ahead and fill out all 6 of those, switching each of these logarithmic expressions to exponential expressions. I'll give you a couple minutes to work on that. When you have finished filling out that chart, you're going to check with your table partner because you guys are going to give me all the answers to this. All right, you ready? Almost. Have you checked with your table partner? Because you guys are giving me answers. Okay, let's start with Kaylin. How about that first one? Log base 2 of 35 or 32 equals 5. What would you write that as? Good. How about Alex Downing? Next one, over here. Good. Let's go to our next row here, Dylan. Good. Jared, how about that next one? This second row, second one over. Good. Now, I don't know if you put this in parentheses. It's not like the end of the world if you didn't. Although we really should, because it does. The -2 should apply to both the 1 and the 5, and if you don't put it on there, it kind of looks like it just goes to the 1. So might be a little side note on that one. I would just so you know why I put that there. Okay. Now the next row might require a little bit of conversation. Does anyone feel comfortable sharing their answer to this first one? Tanner, what'd you got? That required us to remember the base of logarithm, the standard base of logarithm, if it is not written, right? Okay, same kind of thing is happening in that next one. We got to remember what that's standing for. Jonathan? Base E, right? E to the 8, and they will never write 10, they will never write E. Are we expected to know that? Absolutely, okay? Any questions on that? Move to that next table. All of those are in exponential. You are going to rewrite them as logarithmic, and I will help you. This one that is super tiny on your worksheet, it says 3/2. 9 to the 3/2. Again, I'll give you a minute to get those rewritten, and then we'll put answers on the board. Three halves. If you do get done before I start putting answers out there, you can check with your table partner and make sure that you guys are agreeing. Okay, the first one is going to require a little bit of discussion before we move on. Michael, can you give me your answer to that very first one? Doesn't it kind of look like he left off one of the numbers? As I walked around, I did see a lot of papers that said this instead. Is one right or wrong? No, it is very similar to the idea of writing 1x versus writing x. Aren't they the same thing? Okay, and do we really have to write the 1x? No. But is it technically wrong if I write 1x? No. So yes, you would see this in a math book, you'd see that in a math book. But is that what it means? Absolutely. So if you wrote log base 10 of 100, that's fine. Okay, let's move on to the next one. The one that says 9 raised to the 3/2 equals 27. How about Alex Roberts? How did you write your answer for that one? How do you do? Good? Okay. Next row. Let's go with Brogan. Very good. Okay. McGuire, how about the next one? It's weird to say these, aren't it? Sorry. Log base of 1/8. Yep. Yeah, getting all those little, what are those words called? I'm not an English teacher. It's the small words, log base of article. Is that an article? I passed English at one point in my life.
What are those fanboys called? For and but.
Right? Yeah, those.
Junction.
Yes, I was getting there. Anyway, moving on. Jude.
Oh, yeah. I said log base C of 5 is x.
Guess what?
Natural log. Come on. Now.
LN. Okay, now.
Oh. Took me a moment.
Okay. Now I'm couldn't have asked for that to happen at a better time because we just talked about would I check it wrong here versus here? No. Would I check it wrong here versus here? Yes, I would. We do need to recognize that log base E will never ever be written as log base E. You have to move to the natural log part of that one. Sailor, how about you fill in the last one for us? Very good. Any questions? Okay. So moving on from this, I want you to take a second and look at the directions that you see at the top. It says evaluate each log. And I kind of put a little note on there to help you. When it says evaluate, your answer should be a number. Notice on the last couple, we were not getting a number. We were just flipping back and forth. We weren't doing any evaluating. We weren't like solving anything. We were just rewriting the format. Now we're actually evaluating. So we actually should have an answer at the end of this that is a number. Now, I will tell you that my brain works a lot better thinking logarithms through exponential. So I will almost always rewrite this as an exponential problem. You don't have to. That is not a requirement. But I have a hard time thinking about it when it looks like logarithms. So I will flip it to an exponential because that's how my brain works. And whichever way your brain thinks through this better, leave it that way. Okay? So if it is log base 17 of 17, it means that this base of 17 is being raised to something to give me 17. 17 raised to something gives me 17, and my answer is that something. What is that something? 1. If I want to raise a number to something and get the exact same number, that needs to be a 1. Okay? 5 raised to something gives me 1. Okay, so how do I raise something to a number and get 1? 0. Anytime that my answer, and we're going to come back to this, anytime the answer is 1, anytime it's the log base anything of 1, our answer is 0. Okay? And over here, anytime it is log base anything of that same thing, our answer is 1.
What if you had a log base of 1?
We can't have a base of 1. Yeah, that's why. That's why. Because if you raise 1 to anything, it's going to stay 1. So you'll never see a log base 1. Last one, 2 raised to something equals 8. Now this is a very basic example, but guys, I don't expect that you know the powers of every number. And so I'm going to use a really easy number like 2 to work with. If I don't know 2 raised to what gives me 8, and you don't get a calculator, you might have to just off to the side, keep multiplying 2, start with 2 to the first equals 2. If I multiply that by 2 again, that would give me 2 squared, right? 2 times 2 is 4. Multiply by 2 again, that would give me 2 cubed, and that is 8, and that's what we're looking for there. And I used 2, but what if it was like 8 to the third, or 9 to the third? I don't have those memorized necessarily. I can sit there and just do a little nice multiplication, okay, work my way up to whatever number that is. The answer is it would have had to be 3. You will not get a lot of ugly ones, but there will be a time or two that you might have to sit there and multiply 9 times 9 times 9 and figure out what 9 to the third or 9 to the fourth is. But we won't go they won't be super big, and it won't happen very often. Usually it's ones that you will know pretty well. This is a little preview into where we are heading eventually, but we'll see some kind of light exponential equations here where the biggest thing is you want to get is the same base. If you have the same base on both sides, doesn't it make sense that the exponents would have to be the same too if it's saying that they're equal? 4 raised to something equals 4 raised to, well, the same thing, right? So we would be able to then zoom in on our exponents and say that 2x has to equal 3, or that x would equal 3 halves. Okay? Now, that is the end of this next problem where we would head with this, because what if it doesn't start with the same base? You will be able to manipulate to get there. So this kind of uses that concept. If I were to look at this problem right now, I would think exponentially. Log base 16 of 64 equals x. 16 raised to something gives me 64. And sometimes that something is not pretty because that is not a direct whole number exponent. 16 squared is not 64, right? 16 to the first is not 64. So we have to do a little bit of manipulating. Here's what I would suggest. Start with a smaller number. Can I write 64 as 16 raised to something? Not that I know. So then you have to start working with powers of 16. Something that I can square or cube or something to give 16 that I could also do with 64. So this could be through a little bit of trial and error. Any suggestions? 4. 4 works. I can raise 4 to the second to give me 16. And 4 to the what to give me 64? Third. 4 to the third. So they still have to say the number 16. And it still has to say the number 64. It just looks a little different, right? That's still 6. Oops, I put a squared there. Sorry. It's an x. 16 to the x and 64. And then just a reminder on exponent rules. If I have two exponents, I would multiply them together. So that's really 4 to the 2x. And we're back to this problem over here. Okay, so I now do have the same base. And once I do have the same base, I can zoom in on their exponents and find out that x equals 3/2 in this problem, right? That is that problem right there. So sometimes we have to do a little manipulating to get it to be the same base on both sides, but we can. Questions? Okay. This conversation we're about to have on this page and the conversation we're about to have on the next page are very often confused with each other. Okay? So how do we get a fraction? And I'm talking about a fraction inside of our logarithm. How do I raise a number to an exponent and get a fraction? 5 raised to something gives me a fraction. How do I end up with a fraction at the end of that? You guys got it, a negative exponent. So I know my answer is negative because of the fraction part. And then I think, just ignore the fraction and think denominator. 5 raised to what gives me 125? 3. So the negative moves it to the denominator. The 3 is what makes it 125. Okay, so use that to answer the next one. Log base 3 of 1 over 27. Same idea. 3 is getting raised to something, and I end up with a fraction. So again, to move it to a fraction, it's got to be a negative. And then I ignore the fraction part of it. I say 3 raised to what gives me 27. 3 raised to the third gives me 27. The negative is what drops it to the bottom of the fraction. Any questions on that? Okay. Now this one is going from a big number down to a small number. Okay, so now I'm taking, again, the base of the logarithm is being raised to something, and I'm getting a smaller number. It's starting out as the big number, 27 is being raised to something, and the result is a smaller number. Okay, so how do I go from a big number down to a small number? What, a fraction exponent. So this time my answer looks like a fraction. So it's figuring out the denominator of your fraction. So let's talk about how do I figure out the denominator of your fraction. I think the easiest way to do this is think backwards. If I were moving backwards, 3 to get 27, right? So this is my thought process is, well, 3 raised to what would give me 27? That is the denominator of this fraction. And 3 raised to what? 3. So it's the reciprocal of that. That's how we move from big to small. But I can think through it to help me find the denominator. 3 raised to what gives me 27? 1/3 is then my answer. Questions on that? Okay, try this one. I feel like I picked 3 for all of these. Right? Let's see, 125 raised to something equals 5. To go from a big number to a small number, it's going to look like a fraction. 5 raised to what gives me 125? Let's do one that's not 3. I feel like everything's been 3. Let's try bonus question. I don't know. There. Try that one. You and your table partner, figure that one out. Did we figure it out? 64 raised to something gives me 2, right? So I am going from a big number down to a small number. That tells me that it's a fraction. 2 raised to what gives me 64? I hear 5. I hear 6. I think it's 6, right? Squared would be 4, 8, 16, 32, 64, 6. There we go. Not a 3. Questions? And yeah, something like that is absolutely something I could expect that we could do without a calculator. I might have to off to the side or on my fingers or something, think through. But 2 raised to the 6th is attainable mental math, right? Okay. This one we do not see often. You are going to see this one on probably once a worksheet, once a quiz or test, okay? Is that dealing with radicals. So let me write out the steps to it as we go through this one and how I would attack this one. Log base 36 of the square root of 6. First of all, rewrite it as an exponential equation. Okay, so 36 raised to something is going to give me the square root of 6, right? Rewrite it as an exponential equation. The next thing I want you to do is change your radical to a fraction exponent. Okay, so remembering that square root is 1/2. Then I want you to get them to have the same base on both sides. Okay. Earlier we had to change both sides, but always check the smaller number. It's a 6. Can I rewrite 36 as 6 raised to something? Yeah. So it's still going to say 36 here, but I'm going to make it look like 6 squared. 36 to the x, right? Once I have, what?
Something to the 1/2 is the same as square root.
Yes. Whatever your radical is. So if I had like a cube root of that, it would be 9 to this fraction, 1/3. The base of that fraction is whatever root you are doing. Last thing, after we get the same base on both sides, is set the exponents equal to each other. So our exponents are 2x and 1/2. Careful on this one. Divide by 2. What is 1/2 divided by 2? 1/4. Those are ugly. I would not be able to do that without rewriting it this way. Okay, so that is my strong suggestion, because in my head, I cannot tell you what 36 raised to what gives me the square root of 6. Okay, so I strongly suggest going through this plan of attack. Exponential, change it to a fraction exponent, same base. Okay. All right, our logarithmic properties. Let's zoom in on the top up here. The top two we've already talked about. If we have log base something of 1, that's going to be 0, right? We already talked about that raising something to an exponent to get an answer of 1, that exponent has to be a 0. That if I have the same base of what we are taking the log of, then my answer is 1. Log base 17 of 17, right? To raise 17 to something and keep it 17, that something would be 1. It's these two that I want to talk about. If you have a mix of a logarithmic and exponential expression, if they have the same base, your answer is going to be the other number. Okay, so let me give you an example. We'll go the long route, and then just remember that if they have the same base, you're going to get the same, or get whatever other number is in the problem. For example, if we have something like log base 5 of 5 to the 3rd. Okay, same base of my logarithm as it is of the exponent. Now, I could go the long route and say 5 raised to something gives me 5 to the 3rd. Then doesn't it become pretty obvious that that something has to be 3? And what we're going to do is basically get to bypass this. If we have the same base of the logarithm as you have of the exponent, your answer is going to be whatever the other number in the problem is. And we could flip to the other way, an exponential problem. Same base of the exponent as you have of the logarithm, your answer is going to be the other number in the problem. 7 raised to the log base 7 of 4. Okay, if I were to again flip this to being a logarithmic equation, it would be log base 7 of something right? Log base 7 of something equals the exponent. Okay, well then doesn't that something have to be 4? So again, if the base and your exponent of the logarithm and your exponent have the same thing, your answer is whatever other number is in the problem. And we can go the long route, or you can just recognize that situation. Now, our example is not great because it does not obviously show you that, so I'm going to rewrite this example. If I rewrote this as 8 to the third, we can apply that rule. If I have log base 8 of 8 to the third, our answer is 3. Questions? Now that one was actually something I could have worked through. Sometimes it looks like I would need a calculator. Doesn't it look like I would need a calculator for something super ugly like this? 22, log base 22 of 15.2, our answer is 15.2. If the base of the exponent and the base of the log are the same, that's weird. Totally made that one up. That's our example right there.
I was gonna say,
7 log base 7 of 4 is 4. What are the odds of that? I'm sure somebody smart could figure that out, but I know.
there's no way to calculate that.
Okay, now I know that this seems really random, and we've not talked about this numerous times, but just a reminder that a natural log is still just a logarithm with a base of e. It is a base of a number. That number is e, and so it is special and gets to be written as its own terms, but its properties do not change. So this list up here is identical to the list we just had on the last page, specific to base e. Doesn't change anything. I will tell you, it makes these last two a lot harder to spot because you don't see the base repeated. Because it'll say natural log of e to the x. It is the same base of the logarithm as it is of the exponent. So natural log, oh, well, this is the second one, e to the log base e, natural log of 4, they have the same base. And if they have the same base, your answer is the other number in the problem, 4. But it's a lot harder to spot because you don't see the repeated base happen like we did on the last page. Okay? Same thing happens here. Base e, base e. It's so much harder to spot when it is a natural log, but if you have the same base of the logarithm as you have of the exponent, your answer is the other number in the problem, 4.6. Any questions on that? Okay, just finishing up a little bit here on this last part. When we are solving a logarithmic, and we're going to spend a lot more time next week starting this, solving logarithmic and exponential equations, but kind of the lead into that, some very basic ones, is that we can always flip to the other format, and that's kind of what I was encouraging us to do earlier when we were evaluating. But I can do that at anywhere, the x is anywhere in there. And so I could flip this to exponential to think through this. 2 to the third is x, and 2 to the third is 8. Okay? Sometimes when we do that, sometimes when I follow that format, it really can mess with people, and we forget old math. Because we're so in the moment of this whole logarithmic and exponential world that I'll see something like log base x of 243 equals 5. And I'll say, okay, it's a logarithmic equation. To solve a logarithmic equation, I flip to exponential. X raised to the 5th is 243, and I'm panicking at this moment because I don't know what raised to the 5th is 243. But guys, a problem like this, I'll tell you right now, would probably be on your calculator page, and I'm going to rewind us like 6 weeks. If I had handed you this 6 weeks ago and I said the problem is x to the 5th equals 243, solve for x, how do you solve for x? Not square root, but same idea. 5th root, right? You grab your calculator. Well, I know, that's why I said this problem alone, and the next page, would be calculator type problems. But I just want, well, just bear with me for just a second. Sometimes we forget. So sometimes people will get to the point where it says something like x squared equals 64 and panic. Square root it, right? So don't forget old math, and I'm pretty sure that 5th root of 243 is like 3. I'm going to guess 3. And if I didn't know, I'd work backwards. 3 times 3 times 3 times 3 times 3, right? Okay, and yes, there is another page. It's a calculator page. I told you you didn't need a calculator, and you don't, okay? You don't need a calculator, but if I were to type this in my calculator, I just want to show you. I have log of -5, and my answer is error message. Error message is my answer. Why is my answer error message? It's a negative, okay? You are going to run into this right at the beginning of your assignment, and people always get stuck on that problem. Remember, there are 2 places you cannot have a negative. I cannot take the logarithm of a negative. I cannot have a log of a negative, right? That is a rule of logarithms. You cannot take the log of a negative. You cannot have a log base of a negative number. Okay, so keep an eye out for that. Don't get stuck on that problem. There is no work to do. You stop and you say no solution. Okay? Your assignment is a worksheet. You do not get a calculator for this worksheet.